Next we have logical instructions. Okay, and before you learn about any logical instruction, you should know the truth table of those logics. That is, let's start with the very first case, that is AND gate or AND logic. The logic of AND is that if you consider any two bit inputs A and B, let's take all possible combinations here. Output will be 1 only if both the inputs are 1. Okay, in any other case output will be 0. If you know this, there is nothing extra you need to know in order to perform bitwise AND operation. Okay, let's consider the instruction. It will be of this form. So what will be the answer stored in R3? Let's assume R1 has a value 1100. For all logical operation, the values I'm considering here are binary. Okay. If any decimal numbers are given, convert it to binary and then see what values are stored in each bit position. Okay. Let's assume R2 value is 1010. In that particular case, based on this truth table, we know if the first value is 0 and second is 0, what should be the output for AND operation or bitwise AND operation? It is 0. 0 1 is also 0, 1 0 is also 0, and 1 1 is 1. So this is the result that will be stored in R3. Okay, so what we are doing, whatever value is given in R1 and R2, take its binary form, and then based on this particular truth table, we understand that only if both the inputs are 1, output will be 1. Otherwise, output will be 0. Based on that, calculate the answer. That should be the final answer you obtain in the as the result. Okay. What if we consider OR gate? So here we have logical OR operation. Only if both the inputs are 0, output will be 0. If any one input, maybe A or maybe B, is 1, then in that particular case output will be 1. A and B here corresponds to any of the inputs. In our case, R1 is A and R2 is B. Okay. I mean, the individual positions we consider here are A and B. Okay, 0 and 0 output should be 0, 0 1 output should be 1. Here 1 0 is again 1, 1 1 is again 1. So this answer is stored in R3. Okay, so what is this in hexadecimal? It is E. So if you see the final result, you will find E in R3. Okay, next let us consider XOR operation or exclusive OR operation. So what will be the truth table for that? If in case both the inputs are 0 or both the inputs are 1, output will be 0. Only if complementary values are stored, output will be 1. So in that particular case, consider these values. What will be the output? 0 0 will be 0, 0 1 will be 1, 1 0 will be 1, and 1 1 will be 0. Okay, so this result is now stored in R3, and what is the value here? It is 6. Okay, and let's go to the next case, which is nothing but bit clear. Okay, that might be a little different from other operations you have considered till now. This particular case, bit clear R3 R1 R2. In that particular case, what actually we want to do is R1 and not of R2 is actually stored in R3. What do you mean by not of R2? In our case, R2 is 1010, not or 1's complement, or complement of R2 is nothing but inversion of this value. Wherever there is 0, write 1. Okay, this is then compared with arg1, which is 1100, and the result we obtain by ANDing these two is the final result R3. How AND operation works? Only if both the inputs are 1, output is 1, otherwise output is 0, because of which our result is 4. Next we will learn about the compare instructions. Okay, so in case of the compare instruction, the very first instruction which comes into our mind is CMP R1, R2. Okay, what actually happens here is R1 minus R2. Okay, obviously some result is generated. So based on this result, content of CPSR register is updated. Okay, and this result is discarded. We don't need this result. Only based on that, the content of CPSR, that is a conditional flags like N, C, Z, V, these flags, negative, carry, 0 and overflow flags are updated based on this result, and the result is discarded. Okay, and to find the result, subtraction is carried out internally. Okay, and this is very useful for conditional execution or branching. Okay, next instruction that we have to discuss is CMN, compare negative R1, R2. Okay, this, what it will carry out is addition. Internally it will generate R1 plus R2. Obviously some result is generated. Based on this result, it will update the CPSR content. Okay, next we have TST, test. Okay, so what actually happens here is R1 and R2. What is R1 and R2? AND operation is performed between R1 and R2, bitwise AND operation, and the result of that, it is not stored anywhere, but based on the result, CPSR, that is nothing but conditional flags of CPSR, is updated. Okay, and the result is discarded, and this entire operation happens based on the result of AND operation. Okay, so for example, let me take an example where R1 is a binary value. Let's assume it is let's assume all these are 0, just the last value is 1. Okay, out of the total 32 bits, 31 bits are 0, last one bit is 1. And let's assume R2. Okay, 0B, 0, 0, 0, everything is 0. Okay, then what will happen? It is nothing but performing AND operation between 1 and 0. Okay, so what will happen here? What do you know about AND operation? Only if both the inputs are 1, output is 1, because of which answer will be 0. So if I say discard this result but update the conditional flags, what do you think will happen? This is 0, so do you think the Z flag will be set as 1? Yes. What about carry and other flags? All other flags will be set as 0, but Z flag is set as 1. Now this sort of comparison is required in many cases. So if you don't need result of AND operation, but based on that you want to update the conditional flags, in that particular case you can use TST R1, R2. Okay, this performs AND operation, doesn't store the result but updates the conditional flags. And next we have TEQ, which is test equivalence. What this performs is, if there is some instruction like this, it performs XOR operation between R1 and R2 and discards the result but updates the conditional flags. Okay, example, if R1 was 1010, here I am taking binary values. Okay, and if you are performing XOR operation, okay, with R2, which is nothing but 1010 again. What will happen in case of XOR output? What happens in case of XOR? Only if you have inverse values in both cases, like if it is 0 it should be 1 here, if it is 1 it is 0 here, only then output is 1. But in this case all values will be 0, because of which Z flag will be set. Okay, so what we are doing, we are performing XOR. We are not storing the result, but based on the result we are updating the conditional flags. In this particular case, Z flag will be set as 1. This is nothing but logical operations, bitwise AND or XOR bit clear operation. Let's see what is happening here. This value I had taken in the example, so I am taking the same thing. Okay, 12, for your understanding I will write it in binary here so that you know what answer is expected. Okay, now the very first instruction we see here is nothing but AND operation. So in AND what should happen? Only this value will be 1, all other will be 0. Okay, let's see what answer we get. Yes, so we got the answer as 8. Next what we have? We have OR operation being performed. So in case of OR operation, we will see that whenever at least one position is 1, output is 1. And what is this? It is E. Let's see if that is the answer we are getting. Yes. In case of XOR, what should happen? In case of XOR, both are 1 or both are 0, output will be 0. If there is complementary values, output will be equal to 1. What is this? 6. Let's see if that is the answer you're getting. Yes. Then we have bit clear. In case of bit clear, what happens? Instead of taking the second value as R2, okay, we'll take not of that. Okay, what is not of this? It is 0 1 0 1, and R1 we will take as it is. So now if you perform AND operation, you will get 0 0 1 0, and this is nothing but 4. Yes, as expected we are getting the correct answer. So these are about the logical operation. Next we will go to different types of comparisons. The very first is the normal comparison operation that we have seen always. Now we have taken two values, R1 R2. I think we have not modified R1 R2. It is 12 and 10. So we have R1 and R2. This is 12, this is 10. Okay, we are comparing. What you should know in comparison is internally it is performing subtraction. Okay, now this result generated is actually discarded, but based on the result it will update the conditional flags here. That is one thing you should know about every compare operation, whether it is CMP, CMN, TST, TEQ. Okay, all these operations will just update conditional flag and ignore the result. Now 12 minus 10, it is 2, and we know internally subtraction is happening. Because R1 is greater than R2, what you should know is nothing but, is there a borrow generated? No. So immediately carry flag will be set as 1. Okay, that is one of the things you should know. Is the result 0? No. So Z flag will be 0. Is the result negative? No. So N is equal to 0. Is overflow generated? No. So V equal to 0. So only C flag will be set as 1. All other conditional flags are 0 because of this particular compare operation. Okay. So next case is CMN. So here instead of subtraction we are performing addition. So answer here will be nothing but 22. Okay, 22 in decimal. Answer will be in hexadecimal, but that's not required because answer is not stored. Based on this, contents are updated. Is carry generated? No. Is 0 flag set? No. Negative is also 0. Similarly, overflow is also 0. So this will update the conditional flag. Let's see what is happening here. See, new values are updated here. Okay, so this is a simple move operation. We are storing a value 1, and next we have TST operation. In TST, as I had already discussed before, okay, we are performing AND operation. Okay, let me take the two values 1 and 0. If I am performing AND operation, what is the result? Result of this is actually 0. So based on this result, I am updating the conditional flag. So what flag will be set here? Z flag. Carry or any other flags won't get affected by this. Only thing that is changing is nothing but the result has now been modified to 0, because of which Z flag will be set. Next operation is nothing but TEQ. TEQ is nothing but XOR operation being carried out without storing the result, or exclusive OR. Okay, so now very first thing that we see is nothing but first value as 1010 and second value as nothing but 8. So if you perform XOR, what is the result? Okay, so the result is 2, which will be discarded, but any carry or any other flag is updated here. Let's see what is happening. If you notice here, all the flags should be set as 0, because neither there is carry, nor 0, nor negative, nor overflow generated. Okay, so that's how we perform TQ, which is nothing but XOR without storing result.